So the first thing is focus. So we don't do everything from the start. We understand what is feasible, and we do, we support the strategic discussions within OEMs, also with some feasibility studies for the future, but we don't do everything. However, each of these we can address. Let's say about the brake. So one of the biggest differentiators that we have is that we can use a regular brake, and the reason why you can use a regular off-the-shelf brake, it's smaller than in a regular vehicle, is because our motor is very thin. It just really uses not a lot of space. So if the wheels are large enough, then we have enough space both for the motor and for the brake. And the brakes in electric cars, they're really not doing that much work. And the problem that Regen is solving is absolutely the continuous loads, because most of the time you're using Regen, and the maximum loads can still be there even if the brake is slightly smaller. It shouldn't be too small, but even if it's slightly smaller. And here, let's say for the applications where we are currently working towards production, or already, let's say, on the starting production, we are fine with the brakes, with regards to the brakes. Of course, if you look at some niche requirements for track driving, that's where you need to take another look, and you need to understand a little bit better how to combine with Regen. When you talk about unsprung weight, I think there's a big body of work about unsprung weight. The important thing is there's a certain ratio between unsprung and sprung mass, which is deemed to be by suspension engineers okay. And our motors are light enough that we are, for the majority of the vehicle types, that we are okay with regards to the added mass. And that's if you just add the motor. If you engineer the vehicle and the rim and everything around the in-wheel motor, then you can actually achieve a really small differential added mass. Efficiency, very valid point. In city driving, especially stop and go, a geared powertrain will be more efficient. But for electric cars, where energy consumption most matters, especially because of convenience, it's when you're going far. And there, for the customers that we have that are focused on efficiency, we add 10% range. In the worst case, if it's very cold and the gearbox is not operating very, very efficiently, even more than 10%, it's going more up to 15%. So from that perspective, efficiency, you can never get something for free, in physics. There are trade-offs. And here the trade-off that we have is we are focusing on actually what is convenience versus what would be, let's say, a different part of the operation, which does not matter in our opinion so much.